we're going to talk about polygon meshes or polygon modeling. So in the past, well, there still are different types of modeling. One of the major ones used to be Nurbs, which is an acronym for non-uniform rational basis splines. That was used in the past because polygon modeling used to be very blocky or faceted. If you remember 3D models or through anything 3D back in like the 80s or 90s, they look like very faceted or very blocky. Especially look at like PlayStation 1 games or Final Fantasy 7, for example. Then when you're playing it, it looks very, very faceted, flat faces. And so Nurbs was more of a mathematical approach, which used equations to get smooth surfaces or non-uniform or smooth or organic, basically not hard surfaces. Though Nurbs were less intuitive, points were not on the surface and they're more abstract. And due to computation, it was not always accurately designed. And I was mentioning polygons were kind of blocky, and why we were looking for other solutions, because in the past, or 80s and 90s, computers weren't that powerful. So it could get computationally expensive and use up lots of RAM and memory. That's not really a problem these days. We could have millions of points or vertices and we don't have a problem. So probably the most dominant way modeling is done today is with polygons or polygonal modeling. So before we start using the tools, let's explain a little bit of how it works. So polygon mesh or an object consists of points, or also called vertices or vertex. Vertices is a plural of vertex. So a point or a vertex, which looks like, let me bring that down. Could look like this. That's a point. That could be a point. That's a point, or a vertex. This also could be called a vertex and a multiple of vertices, right? So there we have 4 vertices or 4 points. Then you have edges which connect the points. So you could have an edge between these 2 points, an edge between these 2 points, an edge between here, and an edge between here. And when you have at least 3 points and 3 edges, you'll have what's called a face or a polygon. So polygons are the same, like in trigonometry, geometry back in math, where you need at least 3 edges to make a polygon. In this case, it's a triangle, so poly means multiple. In this specific case, it's 3. If you have 4, these are all polygons, but this is a 4-sided. These are also called sides. Edges could also be called sides. So if you had a pentagon, that's 5-sided, but each one of them, the general term is called polygon, meaning the face on there and whatever variable amount of faces or edges or sides they have. So why did it look blocky? Well, if we basically, let's create a new thing here. So what I mean by blocky is basically approximation. You're using these points to try to approximate a surface. So the less points you have, the more flat or faceted it looks. So the example I can think of to illustrate this is, let's say we made a circle like this, right? And let's do that circle. So we have a circle like this. Actually, let's make it a little bigger. I'm talking about more in the thickness of the circle, of the edge of the circle, so you can see it. So I'll make another color for this. So the minimum amount of vertices or points you need, hold on, is 3 to make a face or a polygon. So we have, let's say 1, 2, 3, right? So if I can, these are the vertices or points. If I connect them, you'll get an edge or a side. And once you have them all connected, that's a face or a polygon, right? Now with 3, if you're trying to approximate, let's say a circle or a circular surface, if you only have 3 points, that's what it's, whoops, let me just put this over here. You only have 3 surfaces. If you try to make a circle with only 3 points, it's going to look like a triangle, right? So what you could try to do, okay, let's go back to the circle. Let's say we give you 4 points instead. Your budget is 4 points now. So meaning, when I say budget, meaning you have, you're allowed to use up to 4 points to define your objects or your edges of your objects. Give me a second here. Okay, so instead of having the triangle, which only had 3 points to define a circle, let's say you had 4 points to define a circle. So now you have 1, 2, 3, 4. So you have 4 points that you're trying to approximate the curvature of a circle. Now if you try to connect the edges with your sides over here, and you get rid of the circle, it looks like a square, right? But the square looks closer than the triangle because you had more points there, right? So now, well, if I were to create another one, and let's say you had 5 points to approximate, 1, 2, 3, 4, 5, you see this is getting more round. It's a pentagon, right? It looks more like a circle than a square does, and it looks more like a circle than a triangle does. So you could probably see where you're going with this. The more points you put, the more you could approximate the surface. So let's say you had 6. You probably get the point by now, but just for illustrative purposes, we'll do that. 1, 2, 3, 4, 5, 6, and then we'll connect it here. So we have 6 points or 6 vertices, 6 edges, and as you can see, it gets closer to a circle because you have more points to approximate the surface. And I'll just go straight to 8. So an octagon. So 1, 2, 3, 4, 5, 6, 7, 8. So if I connect them, you see that is more points make it look more like a circle or more matching the curvature. So with that being said, actually I drew it on the same layer, so I'll take that off. So you could imagine if you had infinite points, the more points you had, if you had infinite points like this, well, this is, imagine that's a lot of points really close together. You'll actually approach the curvature of the circle. So the idea of polygon modeling is the same type of idea, where you're using points to try to approximate surfaces.
Thank you for watching. Remember to like, comment, subscribe, and hit the notification bell.